Hi guys, welcome to this video, which is just going to be a short video explaining what structural isomers are. Now, if you've gone through and you've had a look at the videos about naming alkenes and drawing alkanes and having a look at some of those organic molecules, this one's going to be a bit of an addition to that. Okay, now a structural isomer is something that has the same molecular formula, but it has a different structure. All right, so it exists as a different way. So I'm going to show you just a couple of examples of that to explain what we mean. So I'm going to start off with just a simple alkane, C5H12, okay? So this one here, normally, if you just look at the formula for that, you would expect this to be good. Hopefully you have said that it is pentane, C5H12, that's the fifth one along, okay? So pentane there. Normally what you would expect is you'd have 5 carbons in a line like this, okay, and you'd have all these hydrogens around here. So this is the general structure of pentane, 5 carbons, C5H12. However, what can happen in a structural isomer is that we have the same formula, but it gets rearranged slightly. So what we're going to do for pentane here is if we take this group that's on the end, all right, this CH3 group here, if we move that to the middle of the chain, we're going to end up with this. So we're going to end up with 4 carbons. We're going to put the CH3 group, the methyl group there on the chain, and we're going to fill up the rest of these carbons with the hydrogens. And you're going to see that we actually still have the exact same formula of C5H12, but now we actually have a different molecule. This one here is actually 2-methyl-butane. So what we've done is we have moved one of the CH3 groups, okay, and we've now changed what molecule we actually have. They've still got exactly the same formula, but they have a different structure, and they are completely different molecules. This one is pentane, this one's 2-methyl-butane, okay? So a structural isomer is something that has the same chemical formula, but has a different structure. I'm going to show you one more example. The other example I'm going to show you is now where you don't necessarily just have to have an alkane, but you can actually have things that have functional groups as well, and how they can be structural isomers. So I'm going to look at this molecule here, which is butanoic acid. It has the formula C4H8O2, okay? And this is its structure here. I'm going to show you how we can have some slightly different variations of this that don't just move the atoms around, but have completely different functional groups as well. So if you want to work out how you can draw a different structural isomer, what I always do is I always start with the similar sort of carbon chain. So 1, 2, 3, 4 like this. And this time, because we've got a carboxylic acid functional group, I'm going to change it to be an alcohol group, for example. So I'm going to put an OH here, and I'm going to put another OH here as well. So I've got 2 hydroxyl groups in there. So I've changed this from a carboxylic acid into an alcohol. Now, what we want to do is still end up with 8 hydrogens on here. Now, we've already got 2, so if I fill up all the rest of these, 1, 2, 3, 4, 5, 6, 7, 8, I'm going to end up with 10 hydrogens in total on this one, which is not what I want. I only want 8. So every time you want to take out a hydrogen, you need to add in, every 2 hydrogens you take out, you can add in a double bond. So I'm actually going to put a double bond on the end here, okay? And then I'm going to start adding in my hydrogens. And so hopefully what you'll see when we do this, if I've done it right, and there's every chance that I haven't, because I haven't had a nice coffee this morning. All right, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. We've got 4 carbons, so this is C4H8, and we've got 2 oxygens on here. So we've got the exact same formula for here as we had up here, completely different molecule though, okay? This one has alcohol groups in it and an alkene. Now hopefully you can actually name this one. If you can't, that's all right. You might still need a little bit of practice. But we've got 4 carbons here. We're going to name it from this end, all right? So 4 carbons makes it but-1-ene, because the double bond starts on the first carbon. And then on the 3rd and 4th, okay, we've got hydroxy groups. So it's 3, 4 dihydroxy. I hope I've left enough room. There we go. 3, 4 dihydroxy but-1-ene. So that means we've got 4 carbons in a line there. Okay, on the first carbon we have our double bond. On the 3rd and 4th we have hydroxy groups, alcohols. So we've made this a completely different molecule, but still exactly the same formula as we had before for butanoic acid. So hopefully that's giving you a bit of an idea and understanding of what structural isomers are. Best way to do it is just to start picking a formula and see if you can draw different structures, see if you can name them. Right? But they are things that have the same molecular formula, but they have different chemical structures. That's what a structural isomer is. All right, as always, hope you've liked this video. If you've got any questions, just ask, and I'll see you in the next one. Thanks, guys.